Welcome back, aliens. My name is Navin Reddy, and let's continue with the series on Python. In the last video, we have talked about OOPS concept, right? We have talked about objects, we have talked about classes, and then somewhere we have talked about init, right? In this video, we'll focus on two concepts. One is constructor and self. But hold on, we have seen self before, right? But let's try to expand more of it, okay? Because self is something which is very easy to understand. At the same time, it is a bit confusing, okay? So we'll try to get that. And then we also talk about constructor. Now, in the last video, we have talked about init, right? Now, init is actually a constructor, but why it is called as constructor, we'll see that here. And why it is so important. So what we'll do is, let's remove this thing and let's see a computer class again. Let's go back to computer class. So this is a class, right? And of course, every class will have an object, right? As we mentioned, we have a concept of a design, right? So this computer class is a design, and then we need to create an object of it. So what I will do is I will say C1 is equal to computer. Now this computer here is an object, right? I mean, this C1 is an object, or you can say C1 is referring to the object. So what happens, in your system, we have a special memory called as heap memory. Now inside this heap memory, you will get all the objects, right? Example, the moment you say you want an object, now if you remember, we have talked about integers, string, everything is object in Python, right? Now in this scenario, here this object will take some space in your heap memory. Now every space will have some address, right? We have talked about id function, remember? So we can use an id function here and we can print the value of C1. So we can print the address. So of course this object is created somewhere and we need to print the address as well. And the way you can print the address is by saying print, I want to print the address of C1. Let's do that. Oh, we are getting an error. Now if you remember, we have talked about this stuff. So I'm keeping this class empty, right? We cannot do that. So let's write pass because I have not mentioned anything in the class here. So let's write pass. Let's run this code now. And you can see we got the output as 155 with the number, right? Now this is an address, okay? So this is the address of that memory. Now what happens if I create another object? Let's say if I say C2 equal to computer, now we are creating another object, right? So in total we got two objects. So will it take different space or will it be accommodated in the same place? Of course, we have talked about this before when we talked about integers, allocation. If I run this code, you can see we got different addresses. And again, every time you run this code, you will get different address, right? Because every time you run this code, it will create a new object for you. So this time we got two new objects. Now if I run this again, we will get two different objects, not the same object again, right? Because this new execution. So point to remember is every time you create the object, it will take two different spaces. Now question arises, how much space it will take? Maybe 1 MB, maybe 1 KB, maybe 5 KB. So who will decide and who will allocate the memory? Now first of all, the size of the object is dependent upon number of variables we have, or the attributes, if you remember. If this class has 5 variables of different type, it depends upon how much data you pass, it will change the size of it, okay? So the size of the object is dependent upon the size of the variables and number of variables. But who is responsible to assign that memory, or who is responsible to calculate the memory? And that's your constructor. Now this thing here, which is computer brackets, this is your constructor, right? So whenever you write a constructor, it will call the init method for you. Of course, you don't have to call it explicitly, it will be called internally. Now let me define some variables here. How do we create variables, right? So how do we define a variable for the object? Now in this case, if you want to define a variable, we have one choice, which you can define a function which is init. Again, we have seen that. So this is the init function, right? Now it uses self, but as of now, we'll not talk about self. We'll continue here. And I will use two variables. Again, we have talked about this, but let me just do it once again. I will say self.age. I want to have two attributes. One is name. I will say name is Naveen. And age, so we'll say age is equal to 28. So we got two things, we got name and we got age. Now both the object will have the same values, right? So you can imagine we have two objects and both the object have the same value. If I want to change it, if I want to change the value of one object, the way you can do that is, in fact, instead of printing IDs, I want to change it now because of course, right, IDs will print different now, we know that. So we'll say C1 dot, I want to print name of C1 and I want to print the name of C2 as well. So what will happen? Will it print the same data or different data? That's a question. So let's run this code and you can see they are printing Naveen. Of course, right? Because the moment you create the object, both will have the same value because that is what by default you're getting. If you want to assign your own values, you have two choices here. What we can do is before printing it, we can change the value for C1. We can say C1.name is equal to Rashi. So we are changing the name, right? And now if I run this code, you can see we got Rashi and we got Naveen. So of course C1 is different object, C2 is different object, and we got different names. So that perfectly makes sense. We can change the age of C1. We can say C1.age is let's say 12. We got Rashi with age 12. And of course we are not printing age here, but we can do that. So we can change the value of one object from different objects, right? Of course there are two different entities. So remember this, we got two different objects and both the objects will have different variables, okay? You can assign the values there, you can change it your wish. Now question arises, why do we need this self? So what I will do is, just to explain that, let me take one more method here. We'll say def update. Okay, so I'm changing the value of something. And the moment I say update, I want to change age. I will assign a new age. And we'll say age is let's say 30. So we are changing the age now, right? So we got a method which will change the age to 30. Now I want to call update. Now how do you call update? With the help of class name or with the help of object name? Let's try with objects. I will say c1.update. Now see, we have two different objects, right? So but there is program execution, right? So execution will start from here. You got the object, you are changing the names and everything is fine. The moment you say c1.update, your pointer, which is your focus, will move towards this update function or update method. So it is executing it, right? Update will say, okay, I'm getting called, I belong to a class computer, my job is to do something. My job is to change the value of age. But hold on, we got two objects. Which value you want to change, right? Because we are calling update and we are not mentioning which object I'm talking about, because when you call this update, we have not mentioned is it C1 or C2. We have mentioned that by calling it. So we are saying C1.update, but we are not passing anything in the bracket. So when you're calling it, when you're calling update, how your pointer will know which object I'm talking about? Is it the C1 age or is it the C2 age? And that's where you need to use self. So this self is a pointer, or you can say self is directing to C1 or C2. So we have two objects. This self will direct either on C1 or C2 based on what you're calling. So if you're saying C1.update, then in the bracket it is passing C1. So self will be assigned to C1, okay? So that's the importance of that self. It is very important because it is referring to the object. If you have 10 objects and if you want to refer to one object, you can use self. So it is the current instance, you can say. Even if you have 10 objects, at one point you're working with one object, that is self. I hope that makes sense. So that is self, right? So we have talked about constructor and self here. Let me show you one more thing. What if I want to compare two objects here? Okay, so I want to compare. Let's say we have C1, C2 and both have same names, right? So they have same name and they have same age. But let's say I want to compare the age. So I will say if C1 is equal to C2. So I want to compare two people based on their age. If their age is same, I want to print they are same. So I will say C1 is equal to C2, print they are the same. So let's do that. So I want to check if both the objects are same, then I will print they are same. But then I don't want to compare the object address, right? I want to compare their values. I want to compare their age. Name doesn't matter if name is different. What should be same is age. Now in this case, we cannot simply say C1 equal to C2 because we don't know, your Python don't know how to compare. So in this case, what you will do is, you will use a separate function to do that. I will say, hey, I want to compare C1 with C2. So I will say C1 compare, and you can pass C2 because we are comparing it, right? Again, this compare is not an inbuilt function. So if I click on this, you can see it says cannot find declaration to go to something. The thing is, compare is not an inbuilt method we have. So in order to work with compare, you have to define your function. You have to say def compare, and in this compare, of course, you have to pass self, and then you have to also pass one more object which is of C2, right? So we are comparing two objects, right? So we have to pass self. So what is self here? So the C1 becomes self and C2 becomes C2. Again, you can change in the name, it's your choice, right? You can say other, right? So you're comparing self with other. So C1 becomes self and C2 becomes other. Now why C1 becomes self is because C1 is calling it. So C1 is comparing itself with C2. You can reverse it, okay? You can say C2 dot compare C1. In that case, C2 becomes self and C1 becomes other, right? And now once you have this self and other, you can compare. If self dot age is equal to other dot age, you will return true, else return false. In fact, you could have done that in one line, but just to make it look good, I'm doing this. And now you can compare it, right? So they don't have same age because we are changing it after update. Let's remove the update part here. They have the same age, right? Let's run this demo and you can see, oh, we got an error. We forgot to put a colon there, my bad. Let's run this code. And so you can see it is printing they are same. So they are same, right? Now what if they have different age? So what I will do is once I got C1, I will change this age of C1. I will say age of C1 is 30. Anyway, we are not using update here, and we can say run demo, and you can see it is not printing they are same. We should print the else part as well, so that we'll see is it different. Let's print they are different, and let's run this code. Okay, so that we got they are different. Now since their age is different, we are getting that different. See, names are same. What is different is age. So we can compare two objects by defining our own function, which is compare in this case, or method in this case. But remember this thing, compare takes two parameters. The first one who is calling it, and second one whom to compare, right? So here in this case, we are saying C1 dot compare with C2. So C1 becomes self, C2 becomes other. This is very important. I know it is a bit confusing at the start, but the moment you start working on it, it becomes very easy. So that's it from this video where we have talked about compare, we have talked about self, we have talked about constructor. So let me know if you have any questions in the comment section, and do subscribe for further videos, everyone. Bye-bye.